Hey everyone, welcome to another session of CeerazzleDazzle Physics. In today's session we're going to be talking about the wave speed equation. But before we talk about the speed of waves, we need to talk about speed in general. So speed is simply defined as the distance an object travels divided by the time. So speed is equal to distance divided by the time. You may have seen this formula lower down in school. It's now come up again in GCSE Physics. Right, for every single equation, let's now put some units. Time should be measured in seconds. Distance is in meters. Speed is going to be meters per second. Simple stuff. Right, let's give an example then. So let's say we're in a car and we're starting from this location, we're moving all the way to the right hand side. What is the speed of that car? So speed is equal to distance divided by the time. So the distance in this case is going to be 50 meters. Let's put that down. 50 meters divided by the time. How long does that take? The time takes 10 seconds. 50 divided by 10, it's going to be 5 meters per second. Very, very nice and easy. Don't forget the units, because no units equals no mark. Right, now, what about in terms of waves? How do we calculate the speed of a wave? Well, to calculate the speed of a wave, we need to use the following equation. Speed is equal to the frequency of the wave times by the wavelength. So, speed is equal to frequency times by the wavelength. And you need to memorize this formula for the GCSE. It's given by those symbols, so V for speed, frequency by F, and lambda for wavelength. The units of each one of them, let's go. Frequency is going to be hertz. Wavelength is going to be meters. Velocity is going to be meters per second. Easy stuff. So if you have a wave, you need to look at the frequency and the wavelength to tell you the speed. Not too hard to get our head around. Right, let's use a couple of calculations to get familiar with the formula. So, calculation number 1. Test your understanding. What is the speed of a wave that has a frequency of 50 Hz and a wavelength of 3 meters? Once again, what is the speed of a wave that has a frequency of 50 Hz and a wavelength of 3 meters? Right, you know the speed of any wave is equal to frequency multiplied by the wavelength. So therefore, the speed of the wave is the frequency, 50 Hz, times by the wavelength, 3 meters. Therefore, the speed of this wave is 150. What's the unit? It's speed, meters per second. Very nice. Simple stuff. You can use a calculator as well if you want. There's no crime, no shame of using a calculator. That's totally cool with me. Right, scrolling down. Test number 2. What is the frequency of a wave that has a speed of 10 meters per second and a wavelength of 5 meters? So what is the frequency of the wave? So not the speed. So we need to rearrange the formula to make frequency the subject. So frequency is equal to the velocity of the wave, the speed, divided by the wavelength. Right, so what is the speed of the wave? It's 10 meters per second. What's the wavelength of the wave? It's over here. It's 5 meters per second. 5 meters. There we go, not meters per second, just 5. So 10 meters per second divided by 5, the answer is going to be 2 Hertz. Everyone happy? Yeah, make sure you understand where I've come from. We have the frequency, it's speed divided by wavelength. The speed was 10, the wavelength was 5. 10 divided by 5 is 2. The units for frequency is Hertz. That's why I put down Hertz. Okay, now scrolling down. Summary. The speed is equal to the distance divided by time. So we know that, but in general, speed is equal to distance divided by the time taken. And if I'm looking at waves, in order to calculate speed, I can use the following equation. V is equal to F times by lambda, where V is measured in meters per second, frequency is measured in hertz, and wavelength is measured in meters.